Hello everyone, welcome to my channel. In this video, we are going to discuss about Euler's Totient function. Before discussing about the Euler's theorem, we must know that what is the Euler's Totient function. So, what is the Euler's Totient function? That can be denoted by pi of n value. So, that is this value. How we will calculate the pi of n value in the number theory? Now, come to here. Pi of n is the number of positive integers less than n that are relatively prime to n. That means, to calculate the pi of n value, we are going to take that less than n. Those value can be used to determine the pi of n value. Okay, let us see the simple example to calculate that pi of n value. So, simple example is find out pi of 5. So, now what is the given condition here? It is number of positive integers less than n, where pi of 5 means where n value can be considered as a 5. That means less than n means, okay, so that is called as what are the lesser value with the 5. Okay, so that is now number of less than 5 or it may be a 1, it may be a 2 or it may be a 3 or it may be a 4. Totally there are 4 lesser values for n. Okay, so now where n equals to 5, then the numbers less than 5 are 1, 2, 3, 4. Then calculate that what is the GCD of 1 comma 5, 1 with 5, 2 comma 5, 3 comma 5 and 4 comma 5. 1 comma 5, 2 comma 5, 3 comma 5 and 4 comma 5. As we know that how to calculate the GCD of two numbers. Okay, now take the, let us see here 1 comma 5. Now, as we know that one of the method to calculate the GCD numbers here. Okay. Now, what are the divisors of 1? Only 1. What are the divisors of 5? 1 and 5. Now, in the second step, what are the common divisors here? Only 1. So, that is 1. We will get that only 1. In which, to calculate the pi of n value, the value must be a 1, then that can be considered as a relatively prime to particular n value. Okay, and the second one is 1 comma 5 is over and 2 comma 5. What is the 2 comma 5? GCD of the 2 comma 5 means 1 and 2, 1 comma 5. Now the value is common value is 1. So that is a 1 and 3 comma 5. So what is the 3 comma 5? 3 and 5. 1 and 3, 1 and 5. The common value is 1. Okay, 1 and 4 comma 5. Now 4 comma 5. 1, 2 and 4 and 1 and 5 for this one. Okay, what are the common numbers here? Only 1. So that is 1. Okay, so now how we can identify that what is a pi of n value? What are the GCD value is must be a 1. Those values can be considered as a relatively prime to particular n. How many ones are there? 1, 2, 3, 4. Totally 4. Now what is the pi of n value? Pi of n value, that is pi of 5 equals to 4. This is what is the Euler's Totient function. Let us see the one more simple example for this one. Okay, now find out the pi of 11. So now as we know that we are going to calculate that what are the lesser number of particular n. Okay, so that is called as numbers less than 11. What are the numbers less than 11 means? Now 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now calculate that what is the GCD of each and every one with 11. That is 1 comma 11, 2 comma 11, 3 comma 11, 4 comma 11, 5 comma 11 and so on 10 comma 11. Now then can calculate that what is the GCD. 1 comma 11 is a 1, 2 comma 11 is a 1, 3 comma 11 is a 1, 4 comma 11 is the 1, 5 comma 11 is the 1 and 6 comma 11 is the 1, 7 comma 11 is the 1, 8 comma 11 is the 1, 9 comma 11 is the 1, 10 comma 11 is the 1. Totally count that. What are the relatively prime numbers to n? That is called as 11. Okay, what is the values become your 1? Those can be considered as a relatively prime numbers to the n value. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now, what is a pi of 11? That is 10. Okay, like this we will calculate that what is the pi of n value. This pi of n value is called as a Euler's Totient function. Let us see the one more simple example to calculate the Euler's quotient function. Okay, pi of 8. Find out the pi of 8. Now, as we know that what is the first step here? What is the numbers less than 8? Those numbers can be considered here 1, 2, 3, 4, 5, 6, 7. Okay, so those are the lesser numbers for the 8. And now calculate the GCD numbers here. Okay, so that is called as 1 with 8, 2 with 8, 3 with 8, okay, 4, 8, 5, 8, 6, 8 and 7, 8. Okay, so now 1 comma 8 become a 1. Now 2 comma 8 is 2. How? That is a 2, 8. What are the divisors of 2 here? 1 and 2. What are the divisors of 8 here? 1, 2, 4 and 8. What are the common numbers here? Common divisors 1 and 2. Here also 1 and 2. 1 and 2. Now what is the highest value? 2. Now the GCD of 2 comma 8 is 2. That is a 2. Okay, and next one is 3 comma 8. As we know that 1 3 and 1 8. Sorry, 1 2 4 8. Now common number is only 1. And next one is, let us take the 4 comma 8. Now 4 and 8. Okay, what are the common divisors? What are the divisors of 4? As we know that 1, 2 and 4. What are the divisors of 8? 1, 2, 4, 8. Is it right? What are the common numbers here? Okay, 1, 2 and 4. So there is a 1, there is a 1, 2, 2. There is a 4, 4. Okay, so common numbers can be considered here. Now what is the highest value among these three numbers? 4. That is the GCD of 4 comma 8 equals to 4. Now 4. Next one is 5 comma 8 is a 1, 6 comma 8 is a 2. As we know that 6 and 8. Okay, the divisors of 6 is 1, 2 and 3 and 6. Here 1, 2, 4, 8. What are the common numbers here? 1 and 2, 1 and 2. What is the highest value? 2. 2 become a GCD of 6 comma 8. Similarly 7 comma 8. Okay, now as we know that how to calculate the relatively prime numbers to n. Okay, which GCD value is the only one, then those numbers can be considered as a relatively prime numbers to the particular n value. Okay, relatively prime to 8 means 1. Okay, this is not a relatively prime to 8 because of the value is a 2, and 1, 2, this is not a, that is called relatively prime to 8, and this is not a relatively prime to n. So now totally count 1, 2, 3 and 4. So this is what is a pi of 8. So Totient function of 8 equals to value is a 4. So just like we will calculate that what is a Euler's Totient function. Now that is what is a drawback here in the Euler's that is called as Totient function. Now the simple example here, if the n equals to 1000, then it is a time taking process. Is it right? So suppose if you want to calculate that pi of 1000, pi of 2000, pi of 3000, it is a time taking process because of where we are going to calculate that what is a GCD of 1 with what is a 1000, 2 and so on up to triple line. Okay, if it is a value is a 1000, then we will calculate that at triple line. If the value is 2000, then we are going to calculate that 1999 and so on. It is not possible to calculate because of it is a time taking process. That's why we are going to enter into the Euler's theorem. Okay, so that's why we are going to introduce the Euler's theorem in the next video. Thank you everyone.